Today also I'm here with an interesting science lesson, fifth lesson in grade 9, pressure exerted by solid. In this lesson we are going to talk about three subtopics: pressure exerted by solid, factors affecting the pressure, units of pressure. So in previous lesson you learned about force. Pressure and force are two different concepts, but they are connected together. Pressure is caused by the force, but pressure is not the force. So let's see about force, about pressure. When we are talking about pressure, you may have experienced that when the strap of your school bag is narrow, it is uncomfortable to the shoulder. When it is broad, it is not that uncomfortable. As you can see in these two pictures, there are two school bags of equal weight. The shoulder strap of one of them is narrow and that of the other one is broad. Though the strap is narrow or broad, the force exerted by the weight of school bag is the same because two school bags have equal weight. But when the strap of the narrow, its contact area is less, and when it is broad, that area is more. Thus, it's clear that though the force is same, the pressure against the shoulder differs with the area of contact of the strap. Now consider two bags having the straps of the same breadth and different weights of books. The bag with more weight gives more press against the shoulder. The force exerted by the weight of the school bag is distributed throughout the area of contact. It is the distributed force that is felt by the shoulder. When the strap of the bag is broad, the force is distributed over a large area. So the pressure felt by the shoulder is less. In these instances, it is useful to know the force exerted over a unit area. So when we are defining pressure, we can define as the force exerted over unit area is known as pressure. Factors affecting the pressure. Here you can see an activity in your textbook. In this activity, you should place a cake of soap on the plank, which is kept on two tables as shown in the figure. Hang one sandbag on the fire with the center on the cake soap. Increase the number of sandbags one by one using new cake soap in each instances. Measure the time taken to pass the metal wire through the cake of soap. In first instance, number of sandbag is 1. Weight of sandbag is 10 Newton. Time taken to cut through the cake soap. 10 Newton is actually not enough to cut the cake soap. So when we are going to second instance, number of sandbags have 2. Weight of sandbags 20 Newton. Time taken to cut through the cake soap, we can say 20 seconds. If we say 20 seconds, in third instance, number of sandbags 3, weight of sandbags 30, time taken to cut through the cake soap. What do you think? What happened to the time? Yes, it's decreasing because when we increased weight. So in fourth instance, 4 sandbags, 40 Newton, we can say as 10 seconds. Time is decreasing one by one when more sandbags hung. Two factors are relieved by this activity. Their force affects the pressure exerted on a solid object, and pressure increases with the increase of force. So here you can see another activity. As in previous one, you should keep the piece of plank between two tabletops and keep the cake of soap on the plank. Send a thick wire around the cake soap and hang the sandbag of 20 Newton weight. Then remove the thick wire and repeat the above step using thin wire. What do you think about the time? Yes, thin wire take less time, but thick wire take more time. In thin wire, contact area is less, so the pressure is more. In thick wire, contact area is larger than the thin wire, so pressure is low. Accordingly, it can be concluded as follows. The pressure exerted by a solid object on a solid surface depends on the surface area on which the force is acting. Higher the surface area on which the force is acting, pressure becomes low. Higher surface area pressure becomes low. Lower surface area pressure becomes high. You should remember this. According to the above activities, it is confirmed that the pressure exerted by a solid object on a solid surface depends on two factors. They are perpendicular force acting on the surface and surface area on which the force is acting. Pressure is defined as the perpendicular force acting normally on a unit area. Pressure exerted by a solid object on a solid surface can be calculated according to the following formula. Pressure equals perpendicular force over surface area on which the force is acting. This is the formula of finding the pressure. You should remember this formula. Units of pressure. The standard unit of measuring force is Newton, and the standard unit of measuring surface area is square meter. You know this too. So you learn this formula right now. Pressure equals perpendicular force over surface area on which the force is acting. So standard unit of measuring force is Newton over standard unit of measuring surface area is square meter. You have learned in maths when in index lesson, when a denominator is getting to the numerator, index is getting minus. So we are writing as Newton per square meter. Standard unit of measuring pressure is Newton per square meter. It also known as Pascal. Newton per square meter, it is also known as Pascal. Pascal we can represent by capital P and simple A. In honor of French mathematician Basil Pascal, unit of pressure was named after him. 1 Newton per square meter equals 1 Pascal. Now we are going to solve problems on pressure. What is the pressure exerted on the surface of two square meter when a normal force of 300 Newton is acting on it? Let's see how we can solve this problem. You you should remember when you are solving a problem, you should write this formula. 1 mark is given for this formula. Pressure equals perpendicular force over surface area on which the force is acting. Next, you should write 300 Newton and 2 square meters. With 300 divided by 3, you are getting 150 Newton per square meter, or you can write 150 Pascal. Solved example 2. Weight of a cubic box is 400 Newton. It is kept on an horizontal plane surface. Pressure exerted by the box on the surface is 200 Pascal. What is the contact area of the surface of the box? As I told you, you should write this formula. Pressure equals perpendicular force over surface area. We should find surface area. So pressure is moving here. Now surface area equals perpendicular force over pressure. Perpendicular force 400 Newton. Pressure equals 200 Newton per square meters. 0 to 0, 0 to 0. 2, 4, it's 2. Surface area is 2 square meters. Changing the factors affecting the pressure as needed. When cutting, it is easier if the knife is well sharpened. Well sharpening, the knife edge becomes very thin. It can be exert a high pressure on the object, so the object can be cut thinner and easier. The bottom of the skates used by the skiers is made sharp like knife edge. Because of this, a high pressure is exerted on ice. When the skier is skating, that high pressure makes the ice liquefy and form a slippery surface. Roads can be easily damaged because of high pressure exerted by heavily loaded trucks and container carriers. To avoid this, such vehicles are made with a large number of wheels. Then the contact area with the road is increased and the pressure is decreased. Hence, the damages to the roads are minimal. When we are changing the factors affections the pressure as needed. In our day-to-day life, we increase or decrease the pressure according to the requirements. Now I'm telling some instances where the pressure is decreased. As I told you, the tip of nails, drawing pins, needles have pointed end. The skates have a sharp edge on the bottom. As I told you, to increase the pressure and melt ice. Now I am going to tell some instances where the pressure is decreased. Now, as I told you, heavy vehicles are connected with a large number of tires. The bottom part of shoes used by soldiers who remove landmines have a large surface area. Rails or railways are connected with a large number of slippers. Farmers use wooden planks to cut paddy in muddy places. So these are some instances where the pressure is decreased. Now, we actually finished the first lesson, fifth lesson also. So I'm going to chapter whole lesson as a summary. Pressure is defined as the perpendicular force acting on an unit area. The pressure exerted by a solid object on a solid surface depends on two factors: their perpendicular force acting on the surface and surface area on which the force is acting. Formula of the pressure is perpendicular force over surface area. The unit of measuring pressure is Newton per square meter or Pascal. Pressure can be increased or decreased by manipulating the factors which affect on pressure. So, thank you for watching this video and don't forget to subscribe for more videos. Let's meet with you another interesting lesson. Thank you.